So this time, we're going to solve substitution rules for definite integrals, and also we're going to use as reference this list of integrals from Byju's website, byju's.com. So these are the list of integrals that we can refer to if we want to solve for integration problems. And to write my solution here on screen, I am using um, whiteboard. So it's spelled as WITE board.com. So I hope, hi, hello. I hope you will enjoy watching my live stream here in Vigo. So again, for now, we will have an educational recording or educational live streaming. Commonly, I live stream games, but today it's been my fourth day streaming on streaming here, but now we're doing solving problems on mathematics, especially these calculus problems. So I think I've already solved some problems here in the previous videos. So I've solved problems on problem number 1 and I guess problem number 2 as well. So today we're gonna solve problem number 4. So we have here, this is a problem under substitution rule for definite integrals. In substitution rules, we commonly use the method called u-substitution. So it's u-substitution. So I'm using my mouse right now to write on the board. So I hope you understand my penmanship. So sometimes it's called u-substitution method. So we'll start answering number 4. Okay, and that is find the integral of 5 times z minus 4 times the cube root of z squared minus 8z dz. Again, u substitution is used when it is difficult for us to integrate a term, these terms, using the formulas given by Bijou, so the integral formulas for integrations. And here we cannot see any possible integral formula. So we will try to use a different variable, which is called u, to replace or substitute temporarily these terms. So say, for example, if we would let our u be equal to the group or the term which has the larger exponent compared to the other group, for example, for the first group is z minus 4, the second group is z squared minus 8. So here, z squared minus 8z has the larger exponent. So we'll let u be equal to that. So that would be u is equal to z squared minus 8z. Then after, we're going to get the derivative of u. So that would become du. So when we want to get the derivative of a value, for example, or of a variable which has an exponent, then we'll just have to copy the exponent here and become the constant coefficient. Then the exponent will be deducted by 1. So that will be 2 minus 1. Then you'll have minus 8. So the exponent of z is 1. So that would be 8 times 1. Then you'll have z, that would be 1 minus 1. And we should not forget to write dz, because when you get the derivative of a value, then do not forget dz. Simplifying, this will become 2z, since 2 minus 1 is 1. Then we'll have 8. So z to the 0 is 1. Again, any number raised to power of 0, so z to the 0 is equal to 1. Any number raised to power 0 is always equal to 1. And again, we should never forget dz. So that's our du is equal to 2 minus 8 dz. If we take a look at the given, we have here z minus 4, but here we have 2z minus 8. So we want that this term or this part here should be the same with this z minus 4 and dz. So one thing that we can do, if we try to factor out 2, as you can see, uh, 2z and 8 are both divisible by 2. So we can factor out 2. And what would be left are z and 8. So that would be z minus 8. Then that's equal to du. So we're gonna leave this group here at the right side, then we will transfer 2. So for us to transfer 2, we can cross multiply 2 so that it would be transferred to the other side. So that would be du over 2 is equal to z minus 8 dz. So if we are going to rearrange our formula, and so that will become 5 times the integral of the cube root of um, z squared minus 8z. Then that's z times z, the quantity of z minus 4 dz. That means this part here is our u, and this group here is our du over 2. So if we will substitute that one, this will become 5 times the cube root of u times du over 2, which is now a simplified form. So since we have a radical sign here, so that is just equivalent if we would write this one as a exponent in fraction form. So that will be 5 times the integral of u to the power of 1/3. So cube root of u is just equal to u to the power of 1/3. And that's du over 2. But since 2 is constant, we can move it outside the integral sign. So this will become 5 over 2 times the integral of u to the power of 1/3 times du. Then, moving on to the next step, we can now integrate our u. So this will become u to the power of 1/3. So in integration, again, we add exponent by 1, and we will have a denominator, and that would be equivalent to the exponent plus 1. And we should not forget the plus c. So this is now 5 over 3 times u. What is 1/3 plus 1? So if we want to calculate it, 1/3 plus 1 is just equal to finding the least common denominator. So become all over 3. Copy the first term, then plus, multiply it. So that would be 3. And the result is 4 over 3. The exponent, therefore, of u is 4 over 3, and also our denominator is 4 over 3, then plus c. So we can still simplify this if we have a fractional denominator. So we can, if a denominator is a fraction, so it's just equivalent to multiplying with its reciprocal. What what I mean is that that's 5 over 3. So we can multiply it since it's the denominator, then we need to get the reciprocal. So that's 3 over 4. Then multiply by u to the power of 4 over 3 plus c. 3 can be cancelled out. So what would be left is 5 over 4 u to the power of 4 over 3 plus c. And we have to take note that earlier we let u is equal to, where's that? That's z squared minus 8z. So our u is z squared minus 8z. Substituting back the value of u, our answer will then be 5 over 4 z squared minus 8z raised to power 4 over 3 plus c. So this is now our final answer. Okay, now we can actually check if whether our solution is correct or not by clicking this solution, and Paul only shows the important steps and sometimes he only shows the answer to the problem. So say for example here, it shows us 3 steps. So these are the major steps that we need to do in solving the problem. So you have z squared minus 8z. So, oh no, I forgot to write this one. I need to change the category. It's not. Okay, so let's solve. Right, going back. So let's check. Oh no, I might have done something wrong. Okay. Yeah, I have really done something wrong. So this is not 3. What happened? This is not 3. Sorry about that. So it's not able to check that really. Uh, Here. So, so this is 3, but this is not 3, but 2. Sorry, apologies. So this is 2. Then this one should not be 5 over 4, but 15 over 8. So that's why this is 15 over 8, u to the 4 over 3. So this is 15 over 8, u to the 4 over 3 plus c. Then substitute back the value of u. So that's now z squared minus 8z raised to power 4 over 3 plus c. Okay, that is u substitution. So just like me, no, there would be cases that we, because of solving a lot of numbers, sometimes we interchange numbers, so we need to review our answer. So just like this one, I was not able to clearly check that the denominator of 5 is 2 and not 3. Okay, now let's proceed to the next set of problem. So we have here oh no, let's go back to the problem list. That's it's this one, number 5. So let's solve number 5. So what is the integral of 90 x squared times sine of 2 plus 6x cubed dx, quantity of dx. So you can rewrite this ahead. That's 90 times the integral of x squared times sine of 2 plus 6x cubed dx. So the problem here is that we cannot let this one equal to u or neither of these because the result would be different. Because if we let sine equal to u, then the derivative of sine is negative cosine, which is not found here. So since it's given here that it's x squared, then we have a hint that this might be our u. Because if we check the notes or formula, No, we only have here integral of sine x, cosine x, not an integral of an x multiplied by sine x. It would give us a hint again that if we now let's try. Let's just check. No, let's just verify if the assumption is correct. So we have here oh no, if we let u be equal to 2 plus 6x cubed, then we'll get, if we get the derivative of u, that would be du. So this is 0 plus 6 times 3 times x to the power of 3 minus 1 dx. Then 6 times 3 is 18. X to the power of 3 minus 1 is 2. Then dx. Then that would be du. If we check, we only have x squared and dx. So we need to move away, transfer 18 using cross multiplication. So this would be du over 18 is equal to x squared times dx, x squared dx. Then this will become, so let's rearrange first. So we'll have sine of 2 plus 6x cubed. Then that will be x squared dx. So this part here is our u, and this part would be our du over 18. So substituting this, so become 90 times the integral of sine of u. Then you have here du over 18. Then we can move out 90. So that would be 90 over 18 times the integral of sine u du. We can simplify first 90 over 18. Both are divisible by 9. So if we divide 90 by 9, the result is 10. If we divide 90 by 9, the result is 2. But we can still divide them. So 10 divided by 2 is 5. So the result is 5. So is 18 times 5 equals to 90. So that's 4. Yeah, it's actually equal to 90. So the answer is 5 times sine of u du. If we check the integral formulas, we now have this sine x dx. So if we just replace x by u, so this is sine u du is equal to 5 times, we have here negative cosine of u plus c. Do not forget the plus c. Then simplifying further, this will be negative 5 cosine of u plus c, where u is equal to, so if we go back, our u is equal to 2 plus 6x cubed. Okay, so that's 2 plus 6x cubed. Then we will substitute back the value of u, so that would be 5 cosine of 2 plus 6x cubed plus c. And this is now our final answer. So let's try to check if we got the correct answer. We have the same answer with Paul's notes. So it's showing us the first step, let u be equal to 2 plus 6x cubed. The second step is get the derivative of u. Then the third step is get the integral of 5 sine u du, which is negative 5 cosine of u plus c, and substitute back the value of our u, which is 2 plus 6x cubed. So the final answer is negative 5 cosine 2 plus 6x cubed. And this is correct. So that's how we solve using use substitution. Again, if it's difficult for us to integrate a given problem, so we might, one of the things that we can use is u substitution. Okay, let's try other problems. We have number 6. What's this? I'm not familiar with, actually, I forgot the different trigonometric identities or trigonometric laws. So let's just check. We have integral of secant times 1 minus z, okay, times tangent 1 minus z dz. Let's check whether we can find integral of secant times tangent in our formula. Yeah, there is. So we have here secant x times tangent x dx is just equal to secant x plus c. But we have here 1 plus z. Therefore, we will use u substitution. So we will let u be equal to 1 minus z, and our du will be equal to 0 minus dz, or just negative dz. So we'll just write as negative dz, which means our we'll have to transfer the negative sign. So this will become negative du is equal to dz, which means if we will now change this or use u, substitute if u, that's secant of u times, yeah, secant of u times tangent of u times negative du. So we'll just have to move out the negative sign outside the integral sign. So this will become secant of u tangent times tangent of u. Then we have du. Then the integral of this based on the formula is secant of u. So this is now negative secant of u plus c. But remember that our u is equal to 1 minus z. Substituting back u, the value of u, so this is negative secant of 1 minus z plus c. Now let's check if this is really correct. So let's go back to the problem. The solution for this yeah, we did it right. That we will let u is equal to 1 minus z, so that dz is equal to negative u, and that second, the final answer is negative secant of 1 minus z plus c. So we are actually correct in this. All right, so I guess we'll proceed to the next problem. What is the next problem? So, okay. Hmm. Excuse for a moment. How about, what's this? Okay, let's try. mm, Number 7. I don't know how to solve number 7, but let's try. Okay. Number 7. We have integral of 15t to the negative 2 minus 5t. Do not forget the quantity sign. You have cosine of 6t minus 1 plus t squared, then dt. Okay. Okay. I understand now. So this will be our u since it has the largest exponent. Then if we let u be equal to 6t minus 1 plus t to the power of 2, then our du would be equal to, this is negative. So that would be 6 times negative 1 times t to the power of negative 1 minus 1. Remember that we need to subtract the exponent by 1 if it's differentiation. So that we plus t, not yet. So copy, write the exponent, then t to the power of 2 minus 1. So we should not forget to write dt, so derivative of t. Simplifying, this is negative 6t to the negative 2 plus 2 um, t multiplied by dt. Okay, and this is our du. Oh, what shall we do with this? If we try to check, this one is 15t to the negative 2 minus 5t. This is negative 6t to the negative 2 plus 2t. We can factor out, I think, 2. Let's factor out 2 first. Or since this is negative, so we need to factor out the negative sign also. So we have negative 2. So this will become positive 3 t to the negative 2 minus t. Why is this? If we multiply back negative 2, this will become negative 6t to the negative 2. How this one would become negative times negative is positive 2t. So we did not change the real value of these terms, but we just like rewrite them into a different form, a different phase, but they're just the same. They have just the same value. So this is now our du, and that will be du over negative 2 is equal to 3 to the negative 2 minus t quantity of dt. If we check here, we can also factor out 5 because 15 is 5 times 3. So we can have 3 here. So let's just rewrite this. So we'll have integral of 5 times 15 divided by 5 is 3 t to the negative 2 minus 5, factor out 5, so that's just 1. Then we'll have t cosine of 6 t to the negative 1 plus t squared times dt. So let's rearrange them. This is now 5 times the quantity of cosine 6. What happened? That's 6 t to the negative 1 plus t squared times 3t to the negative 2 minus t and dt, derivative of t. Here, we can now substitute. This is our u, and this group here is our du over negative 2. So, substitute. This is 5 times the integral of u, cosine of u rather, times negative du over 2. We can move out negative 1 half. So this will become negative 5 over 2 times the integral of cosine of u du. So referring back to our formula, the integral of cosine is positive sine. So this is equal to negative 5 over 2 times positive sine of u plus c, where u is equal to 6t to the negative 1 plus t squared. Then that is negative 5 over 2 sine of the quantity of 6 t to the negative 1 plus t squared. So this is a semicolon. Plus c. Do not forget to write plus c. So let's check if we got the right answer. But before that, let's review our solution. First, we have negative 2, 5, 2, and negative du over 2. Hopefully, this is correct. Number, this is again number 6. No, no, go back. Let's go back. Let's go back. This is number 7. Number 7. So we have here this, okay, negative 5 over 2 cosine of u. The result is negative 5 over 2 sine of u plus c. And the last is negative 5 over 2 sine of 6 to the negative 1 plus, and it's plus c. Okay, that's it. So let's move back. We're done with number 7. Number 8. What's this? What happened to number 8? Okay, it's the given value is in how do you pronounce it? Euler's number. So this is 8 uh, times the integral of 7, the quantity of 7 y minus 2 y cubed times e to the y to the power of 4 minus 7y to the power of 2. And we have the y. Okay, so we would let q here, so we cannot let e y to the 4th minus 7y squared, I think, be our u, but the exponent of e. So you have u is equal to y to the 4th minus 7y squared. Because if we check, if we get the derivative of 1/4, that should be y cubed. If we get the derivative of y squared, that should be y. But let's check. Get the derivative. We have 4y, 4 minus 1 minus 7 times 2y to the power of 2 minus 1. 1 raised to power, we should not forget to write dy. After, this is now 4y cubed minus 14y, then write dy. So this is du. However, if we check this, so that's negative 2y cubed minus 7. But if we will rewrite this one, um, let's start here first in the du so that uh, we can proceed to the next step. So we can factor out 2, so that what we left is 2y cubed. So we can rewrite this, factor out 2, then what would be left is 2y cubed minus 7y dy. So that, and then if we cross multiply, so that we can transfer 2, so this will become du over 2 is equal to 2y cubed minus 7y, which is the same with this, but uh, they have just different signs. So that one, in that case, we can actually rearrange them. So that's y to the fourth minus 7y squared times 7y minus 2y to the power of 3 dy. So we'll have y to the fourth minus 7y squared. Then let's write 2 to the in first term, 2y cubed plus 7y dy. So for them to have the same signs, we can factor out negative 1. So this will become e to the y to the fourth minus 7y squared is equal to negative 1 times positive 2y cubed minus 7y dy. This is now, we can move out the negative sign since that will become a constant. This one will be our du over 2, and this one, no, not that, but this one here is our u, which means that is now in the form of e to the u du over 2. Let's move out the constant. This will become negative 1 half e times the integral of e to the u du. If we check back the formulas, the integral of ex dx, or if you change it to e to the u du, is just e to the u. So this is negative 1 half times e to the u plus c. But take note that u is equal to y to the fourth minus 7y squared. So this is now negative 1 half e to the y to the fourth minus 7y squared plus c. So this should be our final answer. Let's check. This is number 8. Okay. So our u is this one, y to the fourth minus 7y squared. Step 2, get the derivative. Then we'll have step 3. We have here negative 1 half e to the u plus c. And substitute back the value of our u. So that's negative 1 half e to the y over 4 minus 7y plus c. And our solution is correct. Let's go back to problem list. Okay, let's try problem number 10. Let's check. So we have here the integral of quantity of cosine 3t minus t squared times sine of 3t minus t cubed and quantity raised to power 5 dt. I don't know what to do with this. We have here different exponents. Any suggestion? Shall we do with this? Do we have okay? I think we can let this as our u. Let's try. If our u is sine of 3t minus t cubed dt. What is the derivative of sine? Let's check. By juice table derivatives. Differentiation formulas. Okay. A trigonometric derivative of sine is positive cosine x. But how about when there is a number? I forgot how to get it. Okay. I don't. Oh, it's, I think, product rule. So this could be du is equal to derivative of sine is cosine. So that be cosine 3t times uh I don't know. I forgot. I actually forgot how to product rule. So this will become plus. Mm, I actually forgot. I don't know. So, what's this? Okay, let's search it in the internet. Let's use the power of internet. So what is the derivative of sine 3t? So that is sine 3t is cosine 3t times 3. So it's product rule. Let's have Copilot's answer. 3 cosine of 3t. So that's actually derivative of sine times derivative of 3t. So that is times 3. Then this one is 3t. Now I'll have to remove first dt here. Okay. So this is 3t squared. Then this is now the time that we can have dt. If this is the case, then I guess we can solve the problem. So this will become 3 cosine of 3t minus 3t squared dt. We can factor out 3. So this will become 3 times cosine of 3t minus t squared. Right? Okay. Then du. This will become now du over 3, since what's in the given is only this. You have your cosine 3t minus t squared. So I'll just to write it properly. So this is t squared. Oh no, t squared. Then is equal to again cosine of 3t minus t squared um, yeah, dt. Okay, rearranging the top part, we have that's sine, quantity of sine 3t minus t cubed, quantity raised to power 5 times cosine of 3t minus t squared dt. And here we have let that this whole term here is u, and this one is our du over 3. So this will become u to the fifth times du over 3, or 1/3 times the integral of u to the fifth du. We can now integrate this one. This is now 1/3 times u, that would be 5 plus 1 over 5 plus 1, then plus c, or 1/3 times u to the sixth over 6 plus c. Or we can have 1 over 18, so that's 3 times 6, u to the sixth plus c. And remember that our u is equal to sine of 3t minus t cubed. And then our final answer is now 1 over 18 times sine of 3t minus t cubed all raised to power of 6 plus c. Okay, let's try to check this if we got the correct answer. So we have number 10. So this is now number 10. Number 10. Number 10. So we have, let's just go to the final answer. Okay, this is 1 over 18 sine of 3t minus t cubed, and this is all raised to power of 6 plus c. All right, this our solution is correct, and that's a great news. How about this one? It actually looks very difficult. I don't know. At first look, they are actually very difficult to look at, but let's try to solve them. So integral of 1 of 4 times the quantity of 1 over z minus e to the z quantity times cosine of e to the negative z plus ln of z, then dz. What is this? Okay, let's go first to the integration or derivation formula. Let's check if there is a derivative of 1 over z and also ln of z, because I believe that the derivative and the integral of ez is just e to the z. So it would just only depend on if we have a const sign here. So this would be negative ez probably. Up, yeah, negative e to the power of negative z. But let's check. What is the derivative of 1 over x? Z. Let's just check if this is, can find derivative of 1 over z or ln of z. How about 1 over z? None. None. Okay. Change. Ah, here it is. Derivative of ln x is 1 over x, which means this should be our u. So if we let u be equal to e to the z plus ln of z, then the derivative of u would be negative e to the negative z. Since we have here a negative sign again in derivation, we just multiply the constant value here, or place the constant value here beside the e. Then after that is get the derivative of ln of z, the natural logarithm of z. So that is 1 over x. Then all of these are multiplied by dz. So if we take a look at the given, this will, if we can rewrite it as cosine of e to the negative z plus ln of z times 1 over z minus e to the negative z times dz. Here in the given, we have your negative e to the negative z. But we can use commutative property. So this can be rewritten as 4 times the integral of cosine e to the negative z plus ln negative z plus ln of z times negative e to the negative z plus 1 over z dz. So this is now equivalent to our u, and this whole is our du. And this is 4 times the integral of cosine of u du. If we take a look at the table of integrals, the integral of cosine is positive sign. So that is now 4 times positive sine of u plus c. And remember that our u is equal to e to the negative z plus ln of z. So this is 4 times sine of e to the negative z plus ln of z plus c. Okay, here it is. And let's check if we got the correct answer in problem number 11. Okay, since we're reviewing, then we can open some references, right? So final answer is 4 sine of e to the negative ez plus ln z, correct? Plus c. All right, yeah, hey, back to the problems. So which problem shall we solve? Okay. I think this will be my will this be my yeah, I think this would be my last problem to solve. So let's solve number 17. So we have let's move to number 17. Letter A. So that's the integral of 3x minus 1 plus 9x squared dx. Okay, that's 3x over 1 plus 9x squared. Then you have here dx. Start. If we let our u be equal to, since we have here 9x squared, so that means if we get the derivative of x squared, that will become x. So we also have x here. So this will give us a hint that this denominator will be our u, 9x squared. We get the derivative, this is du is equal to derivative of 1, 0, then 9 times 2 times x to the 2 minus 1 dx, which is equal to 18x dx. So du. Supposedly, we can move out 3x or 3 outside the integral sign. But here, if we notice, 18 is divisible by 3. So we can rewrite this one as uh, 18 divided by 3 is 6. So that would be 3x dx, which is this one, oh, sorry, which is this one here. Okay, so we'll just have to cross multiply, transfer 6 to the other side, so that become du over 6 is equal to 3x dx. And then our integral will become du over 6 over u. Since our u is 1 over 9 plus x squared, so we can move out 6. So that will be, or 1 over 6, so that become 1 over 6 du over u. Now, what is the integral of du over u? That is actually this one. Now, that is 1 over 6 ln of u. So that's absolute value of u plus c. And remember that u is equal to 1 plus 9x squared. Our answer is now then 1 over 6 ln of 1 plus 9x squared plus c. Let's verify if we got the right answer. Solution to A, 17A. So we have here, so that's 1 over 6 ln of 1 plus 9. All right, we got it right. Okay, now, okay, let's just continue B and C. Since they are almost in the same form. For B, we'll have integral of 3x over 1 plus 9x squared to the fourth dx. So if we let u be equal to 1 plus 9x squared, our du is equal to 18x dx. Okay, we have already solved this here above. And our du over 6 is equal to 3x dx. To rewrite this, or substitute u, we will now have du over 6 over u to the fourth, or that is 1 over 6 times the integral of du over u to the fourth. Since the exponent is not equal to 1, then we can use the formula. What's this? We can use this formula integration x to the n. So that would become 1 over 6 times the integral of u to the negative 4 du. Or that is 1 over 6 times u to the negative 4 plus 1 over negative 4 plus 1, then plus c. So that is 1 over 6 times u to the negative 3 over negative 3 plus c, or negative 1 over 18. 6 times negative 3 is negative 18. U to the negative 3, u to the negative 3 plus c. But do not forget that our u is equal to, what's that? U is equal to 1 plus 9x squared. 1 plus 9x squared. Then we have negative 1 over 18 times 1 plus 9x squared quantity to the negative 3 plus c. So if we will rewrite this one, I think this is the final answer. But if we want to rewrite this in a form wherein the power is positive, so this will become negative 1 over 18 times, it's 1. So 1 plus 9x squared raised to power 3, then plus c. So let's check. Show answer. Here it is. Okay, we have, okay, Paul has written the final answer in this form. Okay, but still, they are the same. No? Negative 1 over 18, 1 plus 9x squared raised to power 3. But here, since we put this term in the numerator, so we change the sign to negative 3 and plus c. So it's still correct. Numbers, letter C is quite challenging. I'm not sure how to solve this, but let's try 1 plus 9x squared dx. But if we will let our u be equal to, what's this? How do we solve this one? I actually don't have an idea. Because if we will let this as u, we have here is the derivative of u is 18x dx, but we don't have x in the numerator. I don't know. Oh no. Okay, so let's ask Paul about the solution. Okay, let me think first. Okay, I really don't have an idea, so let's try Paul's answer. Yeah, what? Where is 3x here? We don't have 3x. Okay, it's quite tricky. So what he did is that this one is 3. You have 1 plus 3x squared. All right, that's quite tricky. Then if we let u be equal to 3x, then we'll get du is equal to 3dx, which is now in the numerator. So if we rewrite this, this will become du over 1 plus u squared. I think we have an integral for this. So let's go back to the formula. There should be, I think, in trigonometric one. Yeah, it's actually here a trigonometric integral. So this is equivalent to the arc tangent. Wow, what a problem. So arc tangent of u plus c. And since u is equal to 3x, this is now the arc tangent or the inverse tangent of 3x plus c. Oh no, if I would be given this problem in a real quiz, I might have been able to answer this. So let's check. Let's go back to Paul's answer. Yeah, that is arc tangent of 3x. But that's it. I think I'll have to stop here. In the next video, I'll be solving definite integrals. So far, for the last few days, we are solving indefinite integrals. But to give us an overview, this is how definite integrals look like. Okay. Here, these are called limits, lower limit and the upper limit. So what we will do is that after integrating this part here, we will substitute the values of the limit. Common applications of this is calculating an area. It could be an area of a specific region. For example, if I have a graph here, then I only want to know what is the area in between these two lines. So if I want to know the area in between these two lines, then I can use integration. So if we just know if this is 1 to 4, then I will be able to know what's the integral of this. So that is definite integral. So commonly, indefinite integral is calculating the whole area. So the whole area that would be covered by a certain region. So again, that's just one of the applications of integrals, integration. But for now, let's just end this video and see you in our next session. Thank you.